All right, I'm going to show you something. This is my computer screen, and I Googled YouTube. So I'm on the YouTube site, and I'm going to go into the search at the top, and I'm going to search Jane Leffler. And I'm going to hit the search button, and the very first thing you see is Jane Leffler with this weird little silhouette. And then you see 22 videos. So you're going to click on here, and then it's going to list all my videos. Now your video is not up there yet, but when you go to look for it, you're going to look for Algebra Essentials Benchmark Grading Period 2. This is the algebra, but you're going to look for one that says Algebra Essentials. Okay? That's how you're going to find it. Algebra Essentials. Look for that. Now, here's the benchmark review that I gave you last night. Graphing linear equations in two variables, and it's Algebra 6.0. So the first thing I asked you to do was graph this linear equation, and I gave you 3 random values. So we're going to make x equals 0. So y equals 3 times 0 minus 6. Well, 3 times 0 is just 0, isn't it? So y equals negative 6. 0, negative 6. There's your first point. If x is 2, then we're going to say y equals 3x would be 3 times 2 minus 6. And 3 times 2 is 6. So y equals 6 minus 6. So y equals 0. So the point 2, 0 is going to be on your graph. And then finally, we're going to let x equal negative 1. So y equals 3 times negative 1 minus 6. 3 times negative 1 is negative 3 minus 6. Right here, remember you guys, I told you to circle your terms because you have 3 negatives and you have 6 negatives. And these are all negatives. How many negatives do you have? You have 9 negatives. 2 negatives don't make a positive unless you're multiplying and dividing. And here we're just adding them together, combining them. So there's your third point. So I'm going to graph this. So my first point is 0, negative 6, 0, negative 1, 2, 3, 4, 5, 6. You can do this in your black and white graphing notebook. 2, 0, x is 2, y is 0, so I'm not going anywhere but here. And then the last one, x is negative 1 and y is negative 9. So x is negative 1. My graph isn't big enough, but I can make this work. Y is negative 1, 2, 3, 4, 5, 6, 7, 8. I think it would be about here. Doesn't it look like those 3 points are in a straight line? Sure does to me. You just graphed your equation, didn't you? Okay. Oh, what's the x-intercept? Well, when we find the x-intercept, we make y 0. So when y is 0, x is 2. So that's the x-intercept. What's the y-intercept? Well, for the y-intercept, we make x 0. So when x is 0, y is negative 6. So if you look at your graph, 2, 0 is the x-intercept on the x-axis, and 0, negative 6 is the y-intercept. 0, negative 6 on the y-axis. There's your x and y intercepts. And we also graphed a third point just to be sure. Nice straight line. Okay, number 2. Graph 2x minus 4y equals 8 by finding the x and y intercepts. Okay, so we're going to make x 0. And we make x 0, that's going to find us the y-intercept. Might as well write that. And then we're going to make y 0, and that's going to find us the x-intercept. You should be writing this down or checking your paper. If x is 0, this would be 2 times 0 minus 4y equals 8. Well, 2 times 0 is just 0, isn't it? But be careful, don't cover up. That's a negative 4y. So if negative 4y equals 8, we're going to divide both sides by negative 4. 1 whole times y is y, and 8 divided by negative 4 is negative 2. So 0, negative 2 is your y-intercept. Okay? Now, I didn't leave much room for this other one, so I'm going to add my paper on here. So I'm going to make y 0 now. So 2x minus 4y would be 4 times 0 equals 8. Well, isn't 4 times 0 just 0? So 2x minus nothing is just 2x, isn't it? So I'm left with 2x equals 8. I want x alone. Divide both sides by 2. 1 whole, x equals 4. Okay? So when y is 0, x equals 4. So that's the point 4, 0, and that's my x-intercept. And it says to graph it. So I got my graph paper. You can use your graphing notebook. We have the point 0, negative 2, 0, negative 2, and we have the point 4, 0. X is 4, y is 0. Connect those 2 points and you just graphed your equation. Whoa, that's not a very good line. Using the x and y intercepts. Y-intercept, x-intercept. Touching the x-axis, touching the y-axis. Okay, number 3. Graph y equals 2x minus 5. Ooh, this is going to be easy. What's the slope? Remember, y equals mx plus b. So m is your slope. So your slope is 2. And if we're going to graph it as rise over run, we're going to call it 2 over 1. What is the y-intercept? That's your b value. That's this value, and don't forget it's negative. So the y-intercept is negative 5. So we're going to begin, remember, y equals mx plus b. We begin with this value right here, which is negative 5 on the y-axis. Negative 5 on the y-axis. 1, 2, 3, oops. 1, 2, 3, 4, 5. There's your y-intercept, your b value. And your movement is your slope up 2 over 1. So we're going to go up, begin here, up 2 over 1, up 2 over 1, up 2 over 1. Beautiful straight line. Oh, yeah. Okay. Now, number 4, what is the equation of the line with a slope of negative 1/2? So that means m is negative 1/2 and a y-intercept of 2. Well, my y-intercept is b, isn't it? So b is 2. Well, that's enough information to write the equation. So y if I know m and b, then I'm going to plug that into this. X and y just stay x and y, so I have y equals m is negative 1/2. X just stays x, and b is 2, positive 2. There's the equation of the line that has a slope of negative 1/2 and a y-intercept of 2, and if I wanted to graph that, I would begin at 2 on the y-axis, and I would go down 1 over 2, down 1 over 2. Da, 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 da. Okay? Okay, let's look on the back. What's the equation of the line below? Well, I noticed that this is going uphill, so I know my slope is going to be positive. I notice that it touches the y-axis at positive 1, so I know my y-intercept is going to be positive 1. Now I know my slope is positive, but what is my slope? Well, I'm going to pick any 2 points. So I think I'm going to pick this point and this point, and I'm going to make a slope triangle. I'm going to start at the lower point, and I'm going to rise 1, 2. So my rise is 2. And after I rise 2, I'm going to run positive 1, 2, 3. And my run is positive 3. So my slope is positive 2 over positive 3. That's a positive fraction. This is going uphill. That's perfect. Now that I know m and b, I'm going to plug them into the slope-intercept form of a linear equation. And I'm going to say that y equals, m is 2 over 3, don't forget your x, and b, where I begin graphing, is positive 1. So you begin at positive 1 on the y-axis, and you go up 2 over 3, up 2 over 3. Begin at positive 1 on the y-axis, and you go up 2 over 3, up 2 over 3. So I would have another point about right here. Okay, nice. Find the x and y intercepts for negative 3x plus 2y equals 12. Well, I'm going to make a function table, and I'm not going to squeeze it onto this paper because there's not enough room. So I'm going to give myself lots of room. I'm going to make a function table with x and y. And I'm going to make another column that is my ordered pair. And I'm going to use this equation right here, negative 3x plus 2y equals 12. When I make x 0, that's going to give me my y-intercept, because that point's going to be on the y-axis. And then I'm going to make y 0. And that's going to give me my x-intercept because it's going to be on the x-axis. Okay, so if x is 0, that means, well, wait a minute. If x is 0, isn't this going to be negative 3 times 0? And isn't that just going to be 0? So what's left? Positive 2y equals 12. Divide by 2, divide by 2, y equals 6. So 0, 6 is my y-intercept. It's going to touch the y-axis at positive 6. Now we're going to make y 0. So if I make y 0, 2 times 0 is just going to be 0. So that means 3x, negative 3x plus nothing. Well, negative 3x plus nothing is negative 3x. So I'm left with negative 3x equals 12. To get x alone, I have to divide by negative 3 on both sides of my equation. Negative 3 over negative 3 is 1 whole. 1 times x is x. Positive divided by a negative is a negative 4. So when y is 0, x is negative 4. And that's my x-intercept. That's where it's going to touch the x-axis. Graph. Woo-woo. Negative 1/3 x plus 5. Now look, my slope is negative. Is the top The rise negative or the run? Well, it doesn't matter. It can be either one. So it's negative 1/3. So I can make this negative. Or if I wanted to, I could say y equals 1 over negative 3 plus 5. Both of those will work, and I'll show you. Okay, y equals negative 1/3 x plus 5. So I'm going to begin at 5 on my y-axis. 1, 2, 3, 4, 5. And the first way is down 1 over 3. Down 1 over 3. So begin here and go down 1 over 3. Down 1 over 3. And that'll make us a nice straight line, won't it? Now what if we did it the other way? What if we started with positive 5 on the y-axis? Well, we could just do it on this one. Again, positive 5 on the y-axis, and then we're going to go up 1 and back 3. Well, I'm going to run out of room, but you're still going to see that if I go up 1 and back 1, 2, 3, up 1 and back 1, 2, 3, isn't that still going to be on the same straight line? My first line wasn't drawn very straight. But isn't that still on the same straight line? I believe it is. Pretty sweet, eh? Okay, y equals negative 2/5 x plus 4. Now this one already shows that the 2 is negative, so we'll just do it that way. We'll start at positive 4. We'll start at positive 4 on the y-axis. Positive 1, 2, 3, 4. And then our movement, our slope, is going to be down 2 and over 5. So here's my y-axis. I'm going to go down 2 and over 5. There's my 2 points. There's my line. Well, what if I go, instead of down 2 and over 5, what if I go up 2 and back 5? What if I go up 2 and back 1, 2, 3, 4? Oh, wow. Still gives me my same straight line, doesn't it? Cool. Very cool. Okay, I'm running out of time. I better go. Okay, y equals 3x. How are you going to graph that? Well, this looks to me like y equals mx plus b. What's my b? Nothing there. It must be 0. So I'm going to begin graphing at 0. And my slope is going to be 3 over 1. Begin at 0, 3 over 1. Begin at 0. My slope is going to be 3 over 1. Begin at 0 on the y-axis. That's the origin, isn't it? We're going to go 1, 2, 3, 1. 1, 2, 3, 1. Connect your points. And there it is. Doo, 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 doo. I didn't draw that very well. I'm trying to hold a camera and draw at the same time, but you get the drift. There's a point here, here, and here, and they're all in a nice straight line. So if I used a ruler and really, really, really did a good job, I would have a straight line. What are the x and y intercepts in the graph below? Well, they already graphed it for us. Let's see. Which intercept is this? This is the x-intercept because it's touching the x-axis. So the coordinates here are 2, 0. So the x-intercept is 2, 0. What's the y-intercept? Well, look over here. Start at the point of origin, and x is 0 because we're not going to go to the right and we're not going to go to the left, so x is 0 and y is negative 1, 2, 3. So it's 0, negative 3. Those are your x and y intercepts. And there you have it.